Okay, so today is lesson 3.2, and we're just going to title it Proportions. Make sure you guys put your name, class period, and the date today is 10/25. And the EQ is up on the board. Someone want to read it to me? Okay, go ahead.
What are proportional and non-proportional rates? What are equivalent ratios?
Okay. What are proportional and non-proportional rates? Big words. And then what are equivalent ratios?
Yeah.
Okay. So we're going to answer a lot of questions in this one short page of notes. If you guys want to draw your lines like I did, that will help you organize your thoughts. Okay, the first thing we should probably define is proportion. So that word we'll put on the left in the column. Proportion. And a lot of you guys saw that in your book already. That's just an equation that states two ratios are equivalent. An equation that states two ratios are equivalent. I'm going to underline two ratios and equivalent. What do you guys see in that word proportion? Do you see other words in there? What do you see, Zeke?
Portion.
Portion. Did anybody else notice that? Portion. Portion is like a part of something, right? And fractions are a part of something, right? So that's kind of how it's all tied together there. Yes?
And it's proportional.
Mm-hmm. Pro instead of anti, yeah. What about equations? What is an equation? Like, what are the key elements in an equation? Do you know? Yeah.
Parentheses.
Sometimes they have parentheses. What, like, to make it an equation, what does it have to have in it, Bryn?
Oh, it has to have an equal sign.
An equal sign. Do you guys remember that?
Oh.
Equations have equal signs. So I'm going to give you an example. One thing that you guys learned in 6th grade probably was something like, let me see. I think you might have done this. You might have used letters, but let's do A over B. Just going to use letters, no numbers. Equals C over D. So this is a proportion. We have an equation with an equal sign. We have fractions. Do you remember how to prove that they're equal? There's two ways. Do you remember? You remember? Raise your hand if you remember the two ways. I think the one way that you guys learned was to cross,
Cancel.
not cancel, but
Simplify.
not simplify, but
Reduce.
multiply. Who said multiply?
Me.
Okay, so some teachers taught you this. If you cross multiplied, they would still be equal. So let's just cross multiply. A times D would have to equal B times C, right? That's called cross multiply. Your book will use some of that, But mostly what I'm seeing now is they're trying to get you to, instead of cross multiply, is to just simplify and get to that unit rate. You guys remember your teacher getting to that unit rate instead? So I'm going to show you how to do that one, okay? So, let's see. Let's do like, I don't know, 10 over 2, and that should equal 20 over what? 4. Good. So you remember this. Now I could cross multiply, right? Because 2 times 20 is 40 and 10 times 4 is 40. Or I could just simplify. So what is 10 over 2? 5 over 1. That's our unit rate. Do you see that? And what is 20 over 4?
5 over 1.
Okay, so 2 ways. Cross multiplying or just simplifying to that unit rate. Most of the problems you'll see in 7th grade are not cross multiplying. They're simplifying to a unit rate. Even if you get a decimal or something. You guys saw some of that in your book. Okay, so there's 2 ways to kind of solve it, but most of us in 7th grade are using this second way. Okay, you're going to see questions like this one. So let's do example 1. And your book might say are 5, 6, and 15 over 21 proportional. Are 5, 6, and 15 over 21 proportional? Are they equivalent? That's what that means, right? Are they equal? Raise your hand if you think they're equal. Raise your hand if you don't think they're equal. Raise your hand if you don't know. Okay. Well, let's set them up. Let's put them side by side. So rewrite 5, 6, and then down here write 15 over 21. Is there anything that can be simplified in 5, 6? Like any factor of 5 and 6? No. Any factors of 15 and 21? 3. Good. So let's divide top and bottom by 3. What's 15 divided by 3?
3. 5.
What's 21 divided by 3?
7.
Does 5, 6 equal 5, 7? No. So we write 5, 6 does not equal. Remember that symbol for does not equal? 5, 7. So your answer is no. They are not proportional. They are not equivalent. Could you also cross multiply?
Yes.
Yeah. But you would find out very quickly that 6 times 15 does not equal 5 times 21. It's the same kind of idea, math idea. We're just looking for equivalencies. Okay? All right. Let's do one more. So this is example 2. Are 3/4 and 75 over 100 proportional?
Yes.
Oh, that was fast. You already know? Who says yeah, they are? Some people are still thinking about it, huh? Is this one easier because it's over 100? Because if this is like 75 cents, right? Do you guys see it like that too? That's good that you're seeing it like that. So 3/4 is 75 cents, and look, 3/4. Oh, some light bulbs just went on. So technically you could divide this by 25, right? So I'm going to show you that. 3/4, and then we have 75 over 100. We divide by, what did I say, 25? So this is 3 and this is 4. So yes, that works. Could you turn them into decimals?
Yes.
Sure, why not? That'd be pretty easy, wouldn't it? 0.75, 0.75, you're done. So you don't always have to use the fractions. Okay? Alright, there's a couple more things. Really just one more thing that we need to add under, see where we wrote proportion over here on the left? I'll move it down. Right underneath that constant, because that came up. I forget who said it. Somebody said it earlier. Constant's important, like as in a constant rate. And so let's look at our EQ. What are proportional? So we talked about that. How about non-proportional? Is there anywhere on here where there's a non-proportional thing that we saw? Where?
Example 1.
Good. So next to example 1 over here, put non-proportional. Big word. Maybe like you could put an arrow, like there's the non-proportional one. And equivalent ratios. Let's set one of those up. So, you need to answer that. So on the left-hand side, put equivalent. This is the last thing. Equivalent ratios. And we'll do example 3 like that. Okay? So I'm going to give you a bunch of fractions or ratios, and then we have to figure out, are they equivalent? So I'm going to put 18 over 1, and then 36 over 2, and then 54 over 3, and then 72 over 4. So raise your hand if you think they are equivalent. Raise your hand if you don't think they're equivalent. Raise your hand if you don't know. Yeah. Okay, well let's look at this one. 18 over 1, we already have a unit rate, right? What's 36 over 2? What is that? 18. It's 18. What about 54 over 3? 18. What about 72 over 4? So are they all equivalent? Yeah. So all ratios simplify to, yeah, or 18 over 1. So all are equivalent. This is what those charts are going to bring you to. All those charts you saw? You're going to find the unit rate and see, are they equivalent? Okay, so in your book, we're almost done. We're just going to do a little bit of book, but I'm going to write the page number. We're going to look at page 36, and we're going to look at number 1 and number 2. Page 36, number 1 and number 2. It's the guided practice. I didn't want you to have to rewrite it in your notes because it's kind of big. So we're going to just do it in a book. You guys have that written down, okay? Almost? Okay. You guys found it? Page 36? Do you guys see how there's charts and word problems? That's why I'm not making you rewrite it. Okay? But number 1 says, it says the Vista Marina, you guys see where I'm at? Hold this here in case you still need it. Okay, the Vista Marina rents boats for $25 per hour. Whenever I see that kind of stuff, I circle it or underline it. In addition to the rental fee, there is a $12 charge for fuel. So you're going to rent a boat per hour, but you have to pay for the gas, right? Use a table to determine if the number of hours you rent the boat is proportional to the total cost. Okay. If we rent the boat for 1 hour, so let's just do that. Let's do like 1, 2, and 3. Just go like up to 3 hours, okay? if we rent it for 1 hour, how much is it going to cost us? How much, Bryn?
$37.
How'd you get 37?
Because I added 25 to 12.
Okay, so 25 plus 12 is 37. Do we all agree with that? Okay, so we're going to write after 1 hour it's going to cost 37. Okay. Now, it says something here that's interesting. It says that the boat is $25 an hour, but it doesn't say that the gas is $12 an hour, does it? Does it say it's the gas is per hour?
No.
No. So how much is it for 2 hours then? What do you think, Ryan? 62?
No.
What do you think, Peter?
49.
49?
Yeah. 37 plus 12. My boy.
Miley?
74.
74? There's lots of answers. Tyler?
62.
That's what Ryan said, right? Didn't you?
Yeah.
So I think what you guys are doing is you're adding 25 right here, aren't you?
Not me.
Those two that had the same answer. They're just adding another hour, aren't you? Doesn't say we have to pay more on gas. It just says add another hour. So for 2 hours, it's the 2 times 50 plus the 12, right? Which is 62.
Yeah.
You're right. What about for 3 hours then?
I'm putting in
It's the 75 plus the 12, isn't it?
75.
So, Kayla?
$87.
Okay. So this is like basically saying this, right? Equals 75, but then you have to add the 12. Do you guys see that? So raise your hand if you think it's proportional. Why do you think it's proportional, Kayla?
No, I disagree.
Disagree. Raise your hand if you think it's non-proportional. Who can explain why it's non-proportional? You can?
I think I can.
Okay, go for it.
Because none of them are equal.
None of them are equivalent ratios?
Yeah.
So 37, if I were going to flip this to like 37 over 1, right? A unit rate? Is that the same as 62 divided by 2? What's 62 divided by 2? 31, which is not 37. So now at that point, do I really need to check the third one? No, because I already have 2 that are not equivalent. So for the explain part, we would say no for not equivalent, because 37 over 1 does not equal 62 over 2. And that would be enough to explain our answer. Question?
I was going back in the book.
Mm-hmm.
It said constant.
Mm-hmm.
There's also one of constant of proportional.
Right. There's the constant one too, right?
Constant of variation.
There's a lot of different things. We're not going to do all of them, so don't freak out. Okay, let's do number 2 just so we can finish out this page. So number 2 says, which situation represents a proportional relationship between the hours worked and amount earned for Matt and Jane? So we have 2 tables to compare, right? Okay, so let's look at them for a second. Circle any similarities in the 2. Do you see any similarities?
Yeah.
Which one?
12 and 1.
Okay,
12
so
over 1.
these 2 are the same, aren't they?
Yeah.
Okay. And anything, what is 20 divided by 2? What's that? 10. What's 31 divided by 3? Is that 10? It's a little more than 10, isn't it? And 24 divided by 2 is 12. And 36 divided by 3 is... So what do you notice about Jane's earnings?
Hers is equal. Hers is proportional.
Hers is proportional and Matt's are not, because we go from 12 to 10 to a little over 10.
Yeah, that's wrong.
Okay, so what should we write here? It says, which situation represents a proportional relationship between the hours worked and amount earned? Which one is proportional?
Jane.
Okay, so we write Jane. Jane's money per hour, does that work for you guys?
Yeah.
Is proportional. Because the ratio is constant. Should we use that word? Since it's in our book? In this lesson? Or you could say the unit rate, same thing, is 12 over 1. So you see how they're all related? This proportional, constant, unit rate. It's all the same thing, isn't it?
Same thing.
They're just putting different words on it, but it's all the same. Any questions on that? So what went from like kind of a wordy word problem with 2 charts became not that difficult, right? So maybe it's not as bad as we thought, I hope.